So we're going to have a look at the convex combination of two vectors. Okay, this has got uses for things like robotic arms, so telling a hand how much to grip or how much to move, or for example in a video game to calculate a field of view if you're in a first-person shooter, or maybe the damage done from a weapon to a player. So for example like a shotgun, and how wide the projectile goes and how much damage it can do to a player. Okay, so hopefully you'll kind of see how that works once we sketch it out. So first of all, I've got two vectors, okay, u and v. So I'm just going to go ahead and plot those on my chart. So u is 2, 2. So I'm just going to draw that in there. And v is 1, 3. Okay, so I'm just going to draw that up to there. Okay, now if I draw a line across here at the end of the two vectors, we can imagine this area here in the middle. This is the convex combination of the two vectors, okay, this area. And what we're going to do is we're going to use this formula here to calculate a new vector which should lie inside the two vectors that we have here. Okay, so the way this formula works is we have a times u. Okay, now u is the first vector up here, and a, I'll explain how to get that shortly. Then we add that to b, again, which I'll explain how to get shortly, times v. Okay, and v is our second vector here. Okay, or we could simplify it like that, au plus bv. Okay, obviously u and v, they could be substituted for whatever you call your two vectors. Okay, so I've called mine u and v. Now, when we do this calculation, there are three rules we need to follow which will help us generate the a and b numbers. Okay, so rule number one, u and v are existing vectors. So they are, and I've plotted them on the chart to the right. Now a and b, this is where we can generate the a and b values just here. Okay, so the first rule we need to follow is a and b must both equal 1 when they're added together. Okay, so for example, a could be 0.25 and b could be 0.75. So together they equal 1. Okay, but b, for example, couldn't be 0.8 because that would be over 1. So a and b added together have got to equal exactly 1. Okay, so what I've done is I've chosen down here 0.5 and 0.5. Okay, also a and b must both be above 0. Okay, so a couldn't be 0 and b 1. Okay, so in this case they are, because they're 0.5 and 0.5. So here are the steps in order to get the new vector. Okay, so what we do is we multiply a, which is 0.5, by u. Okay, and we do it for each of the numbers in our vector. Okay, so if you remember up here, u has got 2 and 2. Okay, so 2 times 0.5 is 1, and then the other 2 times 0.5 is also 1. And then we do the same for the other vector. Okay, so we've created b as being 0.5, and our other vector v is 1 and 3. Okay, so we do exactly the same. So we multiply 1 by 0.5, and that gives us 0.5, and we multiply 3 by 0.5, and that gives us 1.5. Okay, now next we do some column addition. Okay, so we add the first column of u to the first column of v. So I'm just going to put it out here just to make it a little bit easier to see. Okay, so that's our u value, and this is our v value. Okay, so we add them together, so we get a new value of 1.5, and 1 plus 1.5 is 2.5. Okay, so this gives us the vector that we need to plot onto our chart. Okay, and what we should find is it will be inside the convex combination area, and it will go up to and not exceed the purple line that we've drawn here. Okay, so let's go ahead and plot that and see if we have done it correctly. So we said it was 1.5 out, so it's about there, and 2.5 up, so that's about there. So if I draw that line, that is pretty much exactly there, right on the purple line. Okay, so we can see actually 0.5 and 0.5 have split our two vectors in half. Okay, now you might be able to think before we do the calculations, but maybe what would be the result of changing those two numbers to 0.25 and 0.75? Whereabouts do you think our new vector might lie? Okay, maybe make a prediction and then go through the calculation step by step and see if your prediction is correct.